Hello, this is section 7.2, Rational Operations. Part 1, Multiply and Dividing Rational Expressions. To multiply rational expressions, we mimic our approach for multiplying numerical fractions. That is, we multiply across the numerators and the denominators. To ease our calculations, it is best to factor and simplify the rational expressions separately before we perform the multiplication. To divide by a rational expression, we multiply by the reciprocal. Example 1. Perform the operations and simplify. So as it was suggested, you should actually simplify before multiplying. So to simplify this, I'm going factor. I can factor a 4 out of the numerator of the first fraction. Can factor a 5 out of the denominator of the first fraction. Can factor a 2 out of the numerator of the second fraction. And this one might seem weird, but I can actually factor a -1 out of the denominator, because then that'll become -4 plus y. Now, it doesn't look like I have anything I can cancel out until you realize that y minus 4 is the same thing as -4 plus y. Those two expressions are the same, so I can actually cancel those out. And now multiplying across, we get 4 times 2 is 8, y plus 3. 5 times -1 is -5, y plus 1. And for good measure, we can distribute, get 8y plus 24 over -5y minus 5. Part B, first thing I'm going to do is change it to a multiplication problem. So I want multiplied by the reciprocal. So this is going to become x squared minus x minus 12 over 5x minus 15 times 5x minus 15 over x minus 2. Now this is one of the rare instances where I'm not going to factor first, but that's just because I already see I have a 5x minus 15 in both positions. So I'm going to cross those out, and then my answer is x squared minus x minus 12 all over x minus 2. Now we do need to see if it can be factored and reduced further. Well, x squared minus x minus 12 is x minus 4 times x plus 3. And that's over x minus 2. Well, it can't be reduced any further, so that last step was kind of unnecessary, but you don't know it's unnecessary until you do it. And part C. We have 3 rational expressions being multiplied together here. I'm going to factor all of them. So this will become x minus 2x minus 1 over x plus 2 times 3x over x minus 2 times 2x plus 2 over x minus 5. Now, any numerator can be canceled out with any denominator. So this x minus 2 will cancel out that x minus 2. And this x plus 2 will cancel out that x plus 2. So then we're left with 3x times 2, which is 6x times x minus 1. And then we're left with x minus 5. And as I'm writing this, I just realized we could have canceled the x's out as well. So then we're left with 6x minus 1 over x minus 5. And for good measure, we can distribute if we want to get 6x minus 6 over x minus 5. Part 2, adding and subtracting rational expressions. Recall from what we know from fractions, we can only add together things that are of the same type. That is, if they're like terms. As such, we needed to rewrite fractions with common denominators. before combining them with addition or subtraction. This same process works for rational expressions, but with more legwork. Recall, to find the least common denominator, we begin by factoring each denominator in our expression, then create a common denominator with all factors represented to the highest power that appears. This time our factors can be polynomials instead of just numbers. There are multiple strategies to find the least common denominator, including Venn diagrams and the vertical combination method discussed in the text. You can use whichever method works for you. Example 2. Perform the following operations and write your answer in simplest form. So for part A, we have 3x over x plus 4 plus 5x plus 1 over 2 times x plus 4. This one's a little easy to see that the LCD is 2x plus 4, because both of the denominators have an x plus 4, but one has a 2, the other doesn't. So in order to combine these, I'm going to multiply by 2 on the top and bottom of the first fraction. So we get 6x over 2x plus 4 plus 5x plus 1 over 2x plus 4. Now combining, we get 11x plus 1 over 2x plus 4. At this step, you would factor and reduce if possible, but 11x plus 1 does not factor, so this is our answer. Part B, 4x squared minus 11x plus 8 plus 3x squared plus x minus 3. And they both have a denominator of x squared minus 3x plus 2. So they already have an LCD. So I'm just going to combine them. We get 7x squared minus 10x plus 5 over x squared minus 3x plus 2. Now I need to factor these. The top, I'm actually going to use the asterisk method to try to factor it. A times c, b, ax, ax. Now, what two numbers multiply to 35 and add up to negative 10? And going through it for a little bit, you'll come to the conclusion, because the only numbers that multiply to 35 are negative 1, negative 35, or negative 5, negative 7. Those are the only possible outcomes that would give us a negative sum. And none of those add up to negative 10, so that means it is not factorable. So I cannot reduce this, so this is our final answer. There is a typo in part C. Part C should read m squared minus 6m over m squared minus 1 minus 3m plus 2 over 1 minus m squared. Now, whenever you see factors like this, what I'm going to do is factor a negative 1 out of the second fraction, because then that'll become negative 1 plus m squared. Now I can take this negative 1 and kind of multiply it to that negative, so it becomes plus. And then realize that negative 1 plus m squared is the same thing as m squared minus 1. So again, these will be the first two steps that you do when your denominators are just backwards of each other. Now I can combine, we get m squared minus 3m plus 1 over m squared minus 1. And again, oh, sorry, plus 2, plus 2. Again, we need to try to factor it if possible, and this one actually does factor m minus 2, m minus 1 over m minus 1, m plus 1. So then the m minus 1's cancel out, and our final answer is m minus 2 over m plus 1. Part D, 6x over x squared minus 4 minus 3 over 2 minus x. Now these aren't backwards of each other, I just really don't like it when it's a number minus a variable. So I am going to factor a negative 1 out of the second denominator, and I'm going to factor the first denominator. So we get 6x over x minus 2, x plus 2, minus 3 over negative 1, x minus 2. Again, I flipped it just to save myself a little writing. This -1, I'm just going to multiply to there to make it positive. And then I hope you realize I just need to multiply my second fraction by x plus 2. And then they will have the same denominator. So we get 6x over x minus 2, x plus 2, plus 3x plus 6 over x minus 2, x plus 2. Combine like terms, we get 9x plus 6 over x minus 2, x plus 2. Factor the numerator, we get 3x plus 2 over x minus 2, x plus 2. So even though I was able to factor it, it's not able to reduce because none of the factors match. Part E, 2u over u minus 1 plus 1 over u plus 2u minus 1 over u squared minus u. So I'm going to factor the u squared minus u. And it, oddly enough, factors into u times u minus 1. So that means that is my LCD. So I'm going to multiply the first fraction by u and u, and my second fraction by u minus 1 and u minus 1. So we get 2u squared over u minus 1, plus u minus 1 over u minus 1, plus 2u minus 1 over u minus 1. Now that all three fractions have a common denominator, I will combine them. We get 2u squared plus 3u minus 2 over u minus 1. Now I'm going to factor the numerator here and just use guess and check. We get 2u minus 1 u plus 2 when we factor it. And then that's u minus 1. And again, the factoring step actually was unnecessary, but we don't know that until we do it. And finally, part F, x over x squared minus 5x plus 6 plus 1 over x squared minus x minus 2. So we get x over x minus 3x plus 2 plus 1 over x minus 2, x plus 1. Sorry, I have a typo in the first one. Should be x minus 3, x minus 2, because it's -3 times -2 gives us +6. Now I need to find the LCD here. This one's actually more complicated than all the other ones we've done. So I usually do a Venn diagram to find the LCD. So you draw like a circle for the first fraction, and then a circle for the second fraction. So I'll just call this first, call this one second. You fill in the middle first, and sometimes the middle is blank. If they have nothing in common, you do blank. So this is the overlap of the first and second fraction. What do they have in common? Well, they have an x minus 2 in common. Then the first fraction also has an x minus 3 by itself, and the second fraction has an x plus 1 by itself. So our LCD is x minus 3 times x minus 2 times x plus 1. Then the Venn diagram also tells you what you have to multiply each fraction by. So this represents the first fraction. So any value that's outside of the highlighted regions needs to be multiplied by the first fraction. So since x plus 1 is outside of the highlighted region, I need to multiply the first fraction by x plus 1. Don't forget, whatever you do on top, you have to do on the bottom. Then, for the second fraction, I need to look at what's outside of this circle. Well, it's x minus 3 is outside of that circle, so I have to multiply the second fraction by x minus 3. So we get x squared plus x over x plus 1 x minus 3, x minus 2, plus x minus 3 over x plus 1, x minus 3, x minus 2. Combine, we get x squared plus 2x minus 3 over x plus 1, x minus 3, x minus 2. And then factor. So the top factors is x plus 3, x minus 1 over x plus 1, x minus 3, x minus 2. And that is it for section 7.2.